Okay, so in this particular case, we've been presented with a hydrocarbon with the empirical formula C₇H₁₅ and a molar mass of 198 grams per mole. And we've been asked to work out the molecular formula. So how am I going to approach this? Well, looking at this, I recall the fact that, okay, well, empirical formula is what? Empirical formula is the simplest, and some people would say the smallest whole number ratio between the atoms of each element present in the compound, right? And so that's what we've been presented, C₇H₁₅. And the molecular formula is the formula that shows the actual number of each atom of each element present in the compound. And we've been told, okay, that is the 198 grams per mole. So what's the difference between the two? Well, I would numerically, in terms of trying to work out the numerical difference, I would need to work out the actual molar mass of the empirical formula to do that. So that's what I'm going to do first. And in order to do that, I'm going to need the molar masses of the carbon and the hydrogen, which we're going to effectively just get from the relative atomic masses of those elements, right? So when I go over here to the well, these, it's not the periodic table, right? It's excerpts from the periodic table. We've got hydrogen, we've got the carbon, and effectively the molar masses are effectively simply just the relative atomic masses in each case, right? So effectively what I can say is that the MR of carbon is simply that 12.0, and the MR of hydrogen is 1.0, right? And in this case, the units we're using is going to be grams per mole, right? Okay, so given that, right? Given that, we are now going to effectively do a calculation to work out the molar mass of our empirical formula. So what we're going to do is we're going to multiply the molar mass by each of the constituent coefficients with respect to that specific element, and then do the same for the other one. We're going to sum those. So what does that mean? In practice, simply we're going to do 12, right, multiplied by the coefficient for carbon in this case. So which is going to be 7, right? We're going to sum that with the same but applied to hydrogen. So 1 is going to be the molar mass for hydrogen, right? So we're going to multiply that by 15 in this case. 15 is the coefficient corresponding with the hydrogen, right? And that is going to tell us what the molar mass of our empirical formula is. So if you do have a go, work that out and see what value you actually get, right? And if you do work that out, what you should find is that you get 99. So 99, and then so therefore the MR of C₇H₁₅ is 99 grams per mole, right? Now we need to, based on visual inspection, you can see that the way the 99 relates to 198, well, you know, you can kind of see the relationship between the two, but I'm nonetheless going to kind of systematically go through the calculation steps to work out the multiplier and then apply the multiplier, etc., etc. But I mean, I would say based on visual inspection, you could probably work out what that is. Okay, so effectively with the 99, we're going to take that and we're going to apply the formula, right? So in this case, the formula I'm going to be using is one which is simply just about working out the multiplier. So we're going to say that the multiplier is equal to the molar mass of the molecular formula divided by the molar mass of the empirical formula. Right? Now, we don't have the molecular formula, but we've been told what the molar mass of the hydrocarbon is, and we know that the molecular formula is the actual number of the atoms of each element present. So we know that the MR of the molecular formula is what we've been given. We know it's 198, right? And we also know that we've worked out the empirical formula, so we know that that's going to be the 99. So we have those two values, right? And so if we do that calculation, we're effectively going to get is equal to 198, that's in grams per mole, divided by 99, which is the one we worked out, right? So grams per mole. And if you do work that out, we should find is that that's going to give you a multiplier of 2, right? So therefore the multiplier is effectively 2x, right? And so if we now use this multiplier, and we apply it to what we have, and when I say that, I mean the formula. Let's start with the carbon. So we've got C7. So for carbon, right, we've got 7, and if we multiply it by the multiplier, which is the 2x multiplier, multiply that by 2, what do you get? Well, you get 14, right? And in the case of hydrogen, and yes, by the way, so let's just, if we proceed with this, so 14, that's going to mean that we're going to have a C14, okay? Now for the hydrogen, if we do similarly, in the empirical formula, we've got H15, right? So we're going to start here, we're going to have the 15, multiply that by the multiplier, which is 2, it's going to give us 30, right? So that's going to be H30, right? And based on those, if we now condense that, create a formula out of it, what do we get? Well, we get, well, I see, anyway, C14, H30, right? So condensed may not have been the best word since we are dealing with chemistry, but I didn't mean that literally. Okay, so yeah, so this would be, in this case, our molecular formula, right? Applying the 2x multiplier to C7, C7H15, we then get that C14H30, okay?